Hello, everyone. So far, we have discussed the basic structure of a C++ program, right? And we also were able to write a small C++ program, which was taking data from the user, and then it was displaying the result to us, right? So we have some idea of data type there, right? So, for example, we declare num1 and num2 and total uh, three numbers there, and all of them were integer types, right? And then we use them in our program, right? So let's discuss the data types in programming, right, here in little bit more detail, right? So in programming, we deal with different types of data, right? The data could be numbers, characters, sequence of characters, which are also known as strings, and then the data may come as binary data, raw data, right? And these different types of data, they require different storage in memory, right? And they need different representations for their values in terms of zeros and ones, right? And we know that all the information that we process, right, all the instructions that we execute, they are written in sequence of zeros and ones. So computers store zeros and ones, but how they will distinguish that whether a number is basically an integer or a character or a sequence of characters like string, right? So they need different representation for that, right? So in C++, we have following data types, and you can categorize them into basic and derived categories, right? So basic data type, which are also called primitive data type, they are basically we have integers, right? And then we have floating point numbers, right? Then we have character, we have Boolean, then we have derived data type, which can be created using the basic data type or primitive data type, right? So we have arrays, we have structure, we have union, class, enumeration, etc., right? So let's now explore these data types. Basically, we'll focus on the primitive or basic data type, and later on, we'll learn about the derived data types in our course. So integer is a data type which basically stores a whole number, right? For example, it may store a number like 10, 224, 32,767, negative 125, negative 2048, right? So you see that all these numbers, right, that you are seeing here, they're whole numbers, right? So if you have a problem where you are working with data and the data can take only whole number values, then you should pick basically integer data type, right? So for example, if I have to store the number of students in the class, I will basically use an integer data type to store the numbers of students in my class. Similarly, you have a floating point data type, right? So floating point data type stores a number with fractional parts, right? So for example, here you see that 3.14, which is an approximate value for pi, right? Then 10.0, right? And then negative 25.7, right? Negative 320.5, and then you have 1.625 raised to the power multiplied with 10 raised to the power 3, right? So this is basically, this is allowed number, allowed representation for scientific notation of this number, right? So you can store numbers which have fractional parts using floating point data type. So if you are working on a data which basically may have fraction part, which may have basically decimal digits, right? So then you should pick floating point data type. Then character data type, it stores only one character constant value, right? And that one character constant value could be a letter, could be a digit, or could be a symbol, right? So for example, here we have character A, and character data type, they are kept inside single quotes, right? Then here you have 8, and then here you have asterisk, right? So these are examples of character data type. And then we have an explicit data type, which is called Boolean. This data type, the variable or constant of this data type can have either true or false value. So true, you can represent it with 1, and false, you can represent it with 0. Then we have string data type, which contains a collection of characters, and they are surrounded by double quotes, right? So for example, we have hello world, right? So which is a sequence of characters which are surrounded by the double quotes, right? And you can use it for basically storing data which can hold, let's say, name of some person, right? Or department of some person, right? So based on your problem definition, you may have such kind of data where you have to store basically name or department or address. So you can use string, right? So these are basically different data types that we will basically talk uh, in the course. And then we later on will go for the derived data type like arrays, structure, classes, and so on, right? So here, few things that you need to remember, that in programming, like 10 and 10.0, they are different. In math, they are same, but in programming, they are different because one is basically integer, right? And another is basically is a floating point number, right? And they will be treated differently inside the computer. Similarly, this 8, which is kept inside single quotes, and the 8, which is without any single quote, they are different because one is character and another is a number, right? So they will be stored differently inside the computer, right? So keep that in mind. So now let's focus on the subtypes within these types, basically, right? Okay. So let's start with character types, right? So character types, if you see that there are a lot of subtypes within the character type data, right? So the most popular used character type is char, basically. So this char, basically, it is 1 byte in size, right? And what is 1 byte? 1 byte is basically a collection of 8 bits, basically, right? So this char is used to store constant character value, right? For example, I can declare a variable, basically. I can declare a variable, it's a char, and let's say that char, right? And this char can hold, let's say, this character A, right? And then there are basically few variants of character types like char 16 underscore T, so which is basically 16 bits character type, right? So these are not common that you will see in the program, but most common character type that we will see in our programs is this one, right? Char. So you have to use char data type to declare a character, right? Then for integer, we have two types of integer. One is called signed integer and another is called unsigned integer. So signed integer, they are whole numbers which can have positive or negative values, right? So for example, negative 10, positive 10, 100, negative 100, right? So they may have positive, negative value, right? And by default, if you write only the integer, or you declare basically any data type, let's say any variable, let's say like this int num, right? So this num is a signed integer. So by default, when you declare any integer that is signed integer, right? Then we have unsigned integer, which may have only positive values, which will have only positive values. For example, 10, 100, they will not have negative value, right? So within each type, basically, we have several basically subtypes, right? And they have different storage capacity, right? So we have like within basically signed integer type, we have also signed char, which is exactly which will take 8 bits or 1 byte. And but here the ASCII value will be used for that character, right? Okay. So signed char, right? And then we have signed short int, right? So this short is basically if you declare a variable like this, sign short int num, right? So then this num will be a short integer which may have positive or negative value, right? Similar, and here you see that the sign and int, they are written in italic manner, right? So it means that they're optional, right? So if I write like here, if I write short num, which is equivalent to basically this sign short int basically, right? So short integer, it will take 2 bytes and it can store a less amount of value, right, in itself. Then we have sign int, right? So sign int is another integer and it will have basically more capacity. It can store larger value than short integer, right? Then we have sign long, right? Int, which can store, let's say, more value than basically an integer or short. And then we have long, which has more capacity than others, right? So these are some subtypes of signed integer type, right? For unsigned integer type, we have also like similar basically uh, subtypes. Like we have short, we have int, we have long, we have long, right? But we have to put basically to make them unsigned, we have to put unsigned before, right? So for example, if you have to declare a data type which is unsigned short, so you have to explicitly write unsigned short, and then you can put this int optionally, right? Okay. So in that way, you can declare basically unsigned integer type, right? So for example, if I write something like that, unsigned int num. So what does it mean? That num is an unsigned integer, so it will have only positive values, right? Okay. Then we have floating point data types, right? So floating point has 3 subtypes, right? So we have float, right? Then we have double, and then we have long double, right? So these 3 types, all of them will have basically fractional parts in their basically representation, right? But they will have basically different storage capacity and the precision, right? So for example, float may have 7-digit precision after the decimal, right? But double may have 14-digit precision after the decimal, right? So they will have basically different precision and different storage, right? So the most commonly used floating point is double, right? So for example, if I have to declare a variable which could have a floating point value, so I will write basically double, and let's say the name of the variable is rate. So then rate is a floating point value, right? And then I can assign value into it. Rate is equal to, let's say, 3.5. And then we have Boolean type. For Boolean type, we'll use basically bool as a data type. And then there are basically other types like void and declare type, right? Okay. So here I have uploaded a program which is called size_values.cpp. And I will encourage you to run this program in your computer to know the different types and their value ranges. Okay. So I would encourage you to try that. So let's focus on the integer here, right? So we discussed that integers, basically, they are whole numbers, right? And in integers, we have different subtypes, right? So we have like signed integer, we have unsigned integer. And within signed integer, we have basically short, we have int, we have long, right? And also we have unsigned counterpart, like unsigned short, unsigned int, unsigned long, right? So these basically different subtypes, they will have different storage to store the numbers, right? And their values, basically ranges will vary basically, right? As we go from short to long, right? So here, when you basically write an integer, right? So you can, if you do not provide any sign, so by default, the integer is positive, right? So if I write, let's say 10, so by default, it's a positive integer, right? But I can also write it like this, 10, right? So I can put a sign here. And then if the number is integer is negative, so I have to definitely put a negative sign, right? So these explicit signs. And commas, decimal points, and special signs are not allowed for integers, right? So for example, here, this thing that you are seeing, it is basically these are valid integers, but here, these are not valid integers because here, this dollar symbol is not allowed. For this one, comma is not allowed, and this one decimal point is not allowed, and here commas are not allowed, and so on, right? So now let's extend our C++ program that we have started with int main return 0, right? So here, So we know that like if we have to include libraries for input and output, so we use hash include IO stream, right? So if we have to use some math function, we will use some math library, like we have to include a math library, which is CMath, right? If we have to use a math function, right? So here we basically include some libraries and other stuff, right? And later on, we will see that we can also declare basically global variables. We can also declare prototype of user-defined function. So we can include other stuff. Then we have this int main, right? And once you basically start your function, right? So you can here at the top, you can declare basically different data types that you are going to use, right? So based on the problem, you have to basically figure out that what will be the type of data that you are going to use, and you have to pick name for that. So type of a data and the name for the data, they are considered as declaration for a particular data, for a particular information, right? Once you declare them, then you can assign values to them, and then you can basically use them in executable statement or input and output statements, right? So that is basically a C++ programming structure, right? So now let's discuss that how do we declare basically, how do we declare uh, data, right? So how do we declare data? Let's see that, right? So here, the format of data declaration is that, so you have to pick a name for the data that you are going to use, and you have to tell the program that what is the data type for that data, right? So let's say, for example, if I want to basically compute the I want to basically compute the average score of this class. So first I should have the number of students in the class, right? Okay. So here I can pick basically the name for the number of students, let's say num, right? And then I have to tell that what is the type of that variable, right? So since numbers like population will be always a whole number, right? And positive whole number. So I can pick basically an unsigned int or int basically for that class size, right? Okay. So here, what is the general format is that whenever you are going to use any data in your program, right? So first, basically, you have to, in the declaration statement, you have to provide the data type. What is the data type of that, basically? Uh, variable, right? And then you have to pick a name for that variable, and after that, you can put basically semicolon, right? So here are some examples, right? So here, let's say in this line, we have declared uh, a variable num, and the type of that variable is integer, right? So we have declared int, right? So num is a variable of integer type. So it can only store whole number, right? So by default, if you write only int, so it will be a signed int, so it may have positive or negative value, right? Here, let's say we have declared a variable ch, and the type of this variable is char, basically, right? So here, ch will store constant character value, right? So for example, we have assigned a value for character A to this C. Okay? And then we have here, we have a value variable, and the type of this variable is a double, so it will store floating point value, and it will have basically decimal digit after the decimal points, right? So once we have declared here, right? So right now they don't have any values, right? We have not assigned any values to them, right? And if you are going to use a variable before assigning any value to them, right? So then they will have garbage values, right? So which is not good, right? So we have to basically assign values to them, and then we can use it, right? So here, let's say we have basically assigned 10 to num, right? So you have assigned that later on, right? And we have assigned the value a to ch, and then value has a value basically num times 2.0, right? So then we have assigned them values later on, right? But we can also initialize the variables during their declaration, right? So for example, here, if you look at this statement, right? So num is a variable of type integer, and we have assigned value 10, right? So you can also do that. If you know that what will be the initial value of a variable, you can basically assign that value during the declaration, right? So this is called initialization, right? Same thing here, ch, when you declare it as a value of, let's say, a, right? And value is a variable which is of type double, and the value you assign it later on in your program, right? Right. So after that, we'll talk about basically the operators which you will use on the data type, right?